In this video, we're going to talk a little bit about the setup for Hooke's Law, which is lab number 5 in your manual. Now here I've got a bunch of pieces all set up as far as that goes, but let me just kind of walk you through the setup. Step 1, it says place pen or pencil on the edge of a surface so that the thick of this portion is extending past the edge. Now some pens and pencils are tapered, and I put pen or a pencil, but a pencil works the best. And you want to extend it just a little bit, 2 to 3 centimeters. Now if you look, I've got this pencil is extended maybe perhaps a little bit longer than 3 centimeters past, but not very much further. And the reason for it is the rigidity of the pencil increases the shorter the length you're working with. Now you're going to be pulling down pretty heavily on that pencil, and that's going to cause one of two things to happen. Number one, if you look at the edge, that's going to be the fulcrum or the point in which the lever is resting. And the mechanical advantage is going to be in favor of the longer side. So if you make it too far out, if you're pulling down with, say, 10 newtons of force, you're going to be pulling up with 10 newtons of force on the other end, if they're even. So we want to make this really short. That way we have a lot of leverage on that end to hold the pencil in place. That's one reason. The other reason is as you pull down on this pencil, if you have a lot of pencil hanging off, it's going to cause the pencil to flex, which is going to throw everything off, plus it could your spring could slip off, break, that sort of thing. So we want to make sure that doesn't happen. So make sure that you only have a little bit of the pencil hanging over the edge, and then for the second step, using the tape the pen or pencil in place. Now I have masking tape here. You can use Scotch tape if you want, but masking tape does the job, and it usually is cleaner to pull off. I said in the second sentence here, I recommend taping it near the end away from the edge as well as a spot close to the edge. The spot close to the edge keeps the pen or pencil from moving side to side. On the other end, that keeps the pencil from flipping. So when you're pulling hard on the end that's hanging off, you're not going to be causing the pencil to fly up and hit you in the eye. Number 3, attach a short spring to the pen or pencil so it is hanging straight down. Keep it as close to the edge of the surface as possible without touching. And so if I bend down here, you'll notice I have my short spring attached, and my focusing is not very good on this camera. It's a much better camera than it is a video camera. And so you want to put it as close to the edge as you can without touching the edge. Again, that reason is the closer it is, the less the pencil will flex, and the less influence you'll have on trying to flip the pencil when you're pulling down. Okay, so now step 4, next to the pen or the pencil, line up the 1.5 meter measuring tape so that the 10 centimeter mark is at the bottom of the spring. I chose and I've had some questions on this. Why the 10 centimeter mark? Why not the 0? Well, in math, it really doesn't matter where you start. It's just a vertical shift up and down on the graph. Now, when you're starting with a measuring stick, I don't like to start at 0 because 0 is usually kind of fuzzy. For example, let me bend this up. Maybe this thing will focus. But if you notice on this, it's probably not going to focus very well. There is no 0. The end of the measuring tape is considered the 0 point. Well, that's pretty fuzzy. The tape doesn't extend exactly to the edge of the metal, and so the question is, how good do they manufacture it? Well, that's one reason for starting down here at 10. In the printing procedure, you're probably going to get a better result. And so I've got it set at 10. Now that's lined even with the bottom of the spring, not the hanger or not the loop that comes from the bottom, but the bottom of the spring itself. And so that's one of the things you want to consider as well. Where exactly are you going to set the 0 point? That's what the 10 centimeters is. It is a 0 point. Now, should you record this as plus 10 centimeters? I will leave that up to you. The error in such a measurement will be subtracted out. And so whatever errors, all errors assuming the same, whatever error there is in 10 centimeters, by the end of it will be effectively reduced to almost nothing when you extend the spring out and take your measurement at the other spots. And so I would argue that there's no need to state that you've started at the 10 centimeter mark. You're not considering the error before that. It's just a spot. You can call it 0 and rename it. It's just a name. All right, what you're looking for is the distance that it travels. The error before the 10 centimeter mark has no bearing whatsoever on the distance of travel after the 10 centimeter mark. Only that between the 10 centimeter mark and the 16.5 centimeter mark are being considered as far as error. I will leave that entirely up to the student, however. Now, fifth and final step says align the 1.5 meter measuring tape so that it hangs straight down. Pull it taut. Don't pull so hard you pull it off the surface, by the way. And tape the measuring tape to the floor. This is to keep it taut, to keep it the same stretched length, so that you're not getting waves and things in the measuring tape. Oop, I'm just about to fall over here. So now, if you look, and this is going to be kind of tough to see. Yeah, I have my kids' stuff out on the floor. But you want to get it as close to straight up and down as possible. You can do this with a plumb bob, which is hanging a weight off a string. The hanging the weight off the string will pull directly towards the center of the earth, which in the local area is straight down to your floor. All right, but you can also pretty well eyeball it, and the error associated with that angle is going to be so minusculely small that you can essentially ignore it compared to the other errors. And so you want to tape that to the floor so that it's nice and taut. At this point, you're ready to start the experiment. And so my first step here, and just to kind of give you an idea of how I'm doing this, is I've gone ahead and I've calibrated my scale so that when I hang it upside down, it's 0. Now you attach the scale to the spring, and you pull the spring down until it hits about 10.5, and then you read the scale. Now you can't let go of the scale at this point because the scale is too heavy. And so you take that reading and you mark and you record your errors for both the distance and the force reading. Then you bring it down to 11, you do the same, 12 or 11.5, do the same, 12, do the same, and do that until you extend it to its maximum point. On the short spring, you don't want to go much past beyond 13 to 13.5. Reason being, you deform the spring. And if you could see my spring a little better, you would see that it is slightly deformed. Okay, it's pulled away. The coils were nice and tight to each other. And now this one's kind of pulled away a bit because I overextended it. So that's the setup for Lab 5, Hooke's Law.